So this is going to show us an kind of an experiment that someone did having to do with force and motion. We're going to see how they did their experiment and what happened when they did their experiment. So again, make sure we have our cameras off. Make sure we have our microphones off. Brianna, make sure we have our camera off.
Welcome to Kids Academy.
Ramps are everywhere, and they help us with everyday things. They can help you get up into a place. They can help you get down or out of a place. They can help you get up a staircase easier. They can help you move heavy objects or move heavy machinery. They can also help you get into your home. Ramps can also be used for fun. And if we're talking fun, there's no place where the ramp is king like a skate park.
So like you said, ramps help us by doing a lot of different things. Sometimes it's for something serious, like getting to school or even getting into our houses, or for work. Some of it is fun, like he gave us the example of a slide, or like we're going to see now, a skate park.
We're here at Chatham Skate Park for a skate lab. Now we know the number one rule when we step into the lab, safety first. Today we're going to be talking about force and motion. Now motion is when things move. Force is when you're either pushing or pulling an object. Now what I'm going to do right now is I'm going to try and pull this big crate of bocce balls, big heavy balls, and try and lift them straight up. Let's see how that goes.
Like he told us, force comes in two big, I guess you could say, kinds. There's a push and there's a pull. So this box here, he's got bocce balls in there. So it's a game where it has like these heavy wooden balls that you throw. He's got a whole case of them. I'm gonna use this rope here and see if he can get them all the way up to the top of the ramp.
Oh, now this is a big heavy crate. You can see it's taking a lot of effort and a lot of work for me to get it up here. Too much. There's got to be a better way. I have here a ramp. Now this ramp can still get me from the ground to the top, but just at a different angle. I'm going to use science and my brain to make it easier. Now I barely even need to pull, and I can get the crate all the way to the top.
You can see it took him a lot less force that time. Even though it was the same crate of bocce balls and it was still going up to the top like it was the first time, you could even hear that he didn't have to work quite as hard. He was pulling it, and because of the ramp and because of the wheels on the skateboard, he didn't have to work as hard to get the bocce balls to the same place.
And my brain even need to pull, and I can get the crate all the way to the top. We got a bit of an experiment set up. We have a basketball. We have a 15-pound kettlebell. And we have a whole box full of bocce balls. So what we're going to do is we're going to put each one of these objects into our skateboard crate of science, and we're going to roll it down this ramp. Then we're going to find out how far it goes, and we're going to mark the distance with each piece of chalk. So first, we'll test the skateboard with just the crate and nothing inside it. Then we'll test it with the basketball. Then test it with our 15-pound weight, and then test it with our bocce balls. Which item, or the empty skateboard, do you think is going to travel the farthest after rolling down a ramp?
I really, really like what he's doing here. He's starting off his experiment very well. He's making sure that number one, he tries the skateboard with the empty box first. Number two, before he even starts his experiment, he's already coming up with a hypothesis, thinking, I wonder which of these is going to go the furthest. He's doing a very good job of making sure his experiment is fair, doing a very good job of going through all the different steps of doing an experiment correctly.
First up is our empty crate. You can see there's a rope in there. The rope is actually tying the crate down so that we don't lose it. I made 2 lines here so I can see where the wheels go to each time, so that each object is released from the same distance. Now let's load up our basketball and see how far this takes us. I want to pull it back to the same place, have my skateboard aiming the same direction. Basketball is in, and let's send it off. Now the basketball, not weighing very much, almost made it to our empty, but came up just a little bit short. Now we're gonna load up our 15-pound weight. Now this is significantly heavier than the basketball. Do you think it'll go farther or not as far as our basketball and our empty crate? And let's send it off. Past the basketball, past the empty crate. There's the basketball, the empty crate, and our 15-pound weight has made it all the way here. Let's make a mark there. We're at the drop line. Now, how far do you think this one's gonna go? Let's send it off. Last one traveled significantly farther. There's the basketball, there's the empty crate, there's the 15 pounds, and our bocce ball made it all the way down here.
It seems the heavier the object on the skateboard, the farther it traveled.
So the only thing I think that he didn't do a great job on is he didn't do a good job of trying to keep the skateboard from going straight ahead. We saw, especially with that last one, that it started to curve and almost like turn as it was going. But like we can still see that even with that turn, that it definitely goes farther the heavier the object in this crate is. So we saw that even with the basketball, it even went a little bit less than if it was empty. But then when he added the weight, it went further, and when he added the whole crate of those wooden bocce balls, that they went even further than that. So the more weight he had in that crate, the more weight was on the skateboard, the heavier it was, the further it was able to roll.
Now let's try launching our skateboard from different heights on our ramp. We have launch number 1, where the back wheels will be at this line. We have launch number 2, where we'll pull the back wheels all the way up to here. And then we have launch 3, where we're going to put the back wheels all the way up here. Which one of these do you think is going to make the skateboard go the farthest?
This was the other thing I liked. He didn't just do that one experiment, he kind of let it start another one. So after he rolled the skateboard the first time and he was just testing to see what the different weights of different things that he put on the skateboard, he started to wonder, I wonder if it changes how high up I put the skateboard. If I put it higher, is it going to go further? Is it going to go less or stay the same?
Here's launch number 1. Launch number 2. And launch number 3.
When I let the skateboard go from down low, it didn't travel very far. The second one a little bit farther, and the third one all the way up the far ramp.
The higher on the ramp I released the object, the farther it went. Now, that's a lot of fun science, but let's use these ramps for what they were meant for.
A little bit farther, and the third one.
So he did see that how high up he puts the skateboard does change it. If it was lower, it doesn't roll as far, but if he puts it up higher or higher, it'll roll even further than that. So back in our Google Classroom, go ahead and turn our cameras back on. I want you to click on the quiz here, and I want you to answer the questions about that video that we just watched.